All right, in this video, I'm going to cover section 2.2, part 2, when we did the inverse norm and the normal CDF. I really want to focus first on when to do these things. So if you have a value and you're trying to find a percent, this is going to be normal CDF. If you have a percentage given to you and you're trying to find a value, this is inverse norm. And you're inverse norming the percentile. Whatever that is a decimal. So I'm going to go through a couple of examples, not necessarily ones we did in class. I'm going to tweak them a little bit. All right, so let's scrap this. Say they want to know what the interquartile range is for this data. So this is on page 3 of our section 2.2 part 2 lesson. This is one we did in class, but we didn't talk about the IQR. So here, the distribution is approximately normal. The mean mu is 250 pounds. The standard deviation sigma is 21 pounds. I'm going to draw, label, and shade the distribution. So I have 250. The IQR I know is Q1 and Q3. And if I'm shading, I want the range of the middle 50% of the data. So I need to understand there's 25% of the data below Q1 and 75% of the data below Q3. So I have percentages. I'm working on getting values so I can find the IQR. So this is going to be inverse norm. So the z-score for quartile 1 is going to come up from doing inverse norm of 0.25 because the first quartile is the 25th percentile. That's going to be negative 0.674. Same idea for quartile 3. It's going to be inverse norm, but 75% of the data falls below Q3. Since they're the same distance away from the mean in terms of standard deviations, one z-score is negative, one is positive. Now I can go to the work. For quartile 1, I take my z-score equals the value, I don't know it, Q1 minus the mean divided by the standard deviation of 21. To do the work, I'm just going to multiply by 21 and add the 250. So if I do that, negative 0.674 times 21 plus 250, I'm at about 235.8. I'll just put the few decimals I have there. And then Q3 is going to look very similar. I take the positive z-score because quartile 3 is above the mean. And if I solve this out, I'm going to have the same kind of idea. 264. Right. The units on both these are pounds. And then I want the interquartile range. So I have to subtract my quartiles, Q3 minus Q1. So if I do that on the calculator, 28.308 pounds. So the middle 50% of the data varies by about 28 pounds. Okay, so that involves two percentages and finding two values to get the IQR. Let's look at another one. Some of you did this in class, this specific question, and put it on the poster, but it's worth talking about again. You want the time between 1.75 and 1.85, what proportion? This is asking for a percentage, and we have values. So this is going value to percent. This is going to be norm CDF. So I can tell really quickly, find the proportion, that's value to percent. In what proportion? That's value to percent. What time is necessary to be in the fastest 3%? That's percent to value. So that's how I'm analyzing those pretty quickly to tell. All right, so find the proportion of laps that were between 1.75 and 1.85 minutes. All right, let's just change this because you may have done this in class. Let's say 1.8 and 2 minutes. So I'm labeling my distribution approximately normal. The mean is 1.84 minutes. Standard deviation is 0.07 minutes. 1.84. And let's see, 1.8 would be here. 2 would be up here. Between. As I mentioned in class, it might be helpful to subtract the standard deviation a couple times. So this would be like 1.77, 1.7, 1.63, 1.91, 1.98, 2.05. Just so you can tell, this z-score is going to be somewhere between 2 and 3, and this z-score is going to be somewhere between 0 and -1. That can be helpful. So now I'm just calculating a z-score for each of the values. The standard deviation is 0.07. And then a z-score for 2. So -0.04 divided by 0.07. This z-score is about -0.57. And this z-score is 2.286. So based on where I'm shading, if I think about the standardized distribution, this would have a z-score of 0. This has a z-score of -0.57. This z-score is 2.286. So I'm doing normal CDF. The lower is -0.57. Upper is 2.286. The mean is 0. Standard deviation is 1. And then I'm just plugging this in. -0.57 to 2.286, which is going to be about 0.7 for the area under the curve, or the probability. Some of the other questions that people were asking is as far as like what do I do with the lower, the upper? So we did a between. Let's look at the other couple of scenarios you could see. You could see a scenario like this. You could see a scenario like this. Those are really the other scenarios you could see. So if it's a left tail or left end, when you do your normal, I'm going to abbreviate NCDF, your lower is -infinity and your upper is whatever this z-score is. It's going to be negative. Your upper is going to be that negative z-score. The mean is always 0. The standard deviation is always 1. I know in Algebra 2 your teachers may have taught you differently, but we use the standardized curve, so we're always using 0 and 1. Here, if it's the same thing, but you're shading above or to the right for normal CDF, your lower is that z-score, whatever it's going to be, in this case, a negative z-score. And your upper is positive infinity because you're shading to the right. Think about a number line. Positive numbers are to the right, negative numbers are to the left. And then mean, standard deviation are going to stay 0 and 1. So hopefully that's helpful and you can kind of see how those go. The last thing I would consider doing is taking a look at the very last page of lesson 2.2. I'm sorry, the second to last page. We were kind of rushed for time here, but part 2 is a good one to do. I'm on page 6. You might want to pause the video and try to work through this. So here's what they tell us. The distribution is approximately normal. They want the standard deviation to remain at 0.05 ounces, but they don't know what they want the mean to be, so we don't know that. You need some information from part A. We don't know what the mean is, that's mu. They only want 1% of cans to be under 12 ounces. So here's 12 ounces, 0.01. Only 1% of cans are there. So I have a percentage. I'm going from a percent to a value. The value that I need is the mean now, not the actual value, but it's still going to be inverse norm. So I'm going to go inverse norm. The percentile would be 0.01. There's 1% of the data below that. And that's going to give me -2.33, which is my z-score. Let me double check that. I'm going off of memory, 0.01. Okay. So -2.33 equals the value 12 minus the mean mu divided by the standard deviation 0.05. So I'm going to multiply both sides by 0.05. Negative 2.33 times 0.05 equals 12 minus mu. So I could subtract the 12. And then whatever this number is equals negative mu divided by negative 1. You don't have to show all those steps, but that's the algebra behind it. So essentially negative 2.33 times the 0.05 minus the 12 divided by negative 1. Oh, you can't see any of that. Times the 0.05 divided minus 12 divided by negative 1. The mean would need to be increased a little bit to that 12.1165 ounces. So I hope these videos were helpful and they kind of captured what you were thinking in class. I'll see you tomorrow.